We're going to apply some of the rules that we learned in our previous lesson when we did pages 2 and 3, and we're going to apply them to problems on page 4. So here's page 4, and the problems that we're going to do on page 4 are 1p, 1q, 1t, 1x, 1z, 3, and 5. So we're going to apply what we learned in the previous lesson on pages 2 and 3 and do some problems. So let's start off with page 4, and we're going to do problem 1p. Here's the equation, and we have to solve this for x. And the first thing we're going to do is apply the distributive rule. So we're going to do 5 times x gives us 5x, plus 5 times minus 3 gives us minus 15, minus 7 times plus 6 gives us minus 42, and minus 7 times minus x gives us plus 7x. Then on the right side of the equation, this 24 is this 24. Minus 3 times plus 8 gives us minus 24. And minus 3 times minus x gives us plus 3x. And this minus 3 is this one over here. Now, what we learned on the previous lesson is that we always want the variable on the left, the variable term on the left, and the number on the right. And we also learned that when we move a term from one side of the equation to the other, we change the sign. So that's what we want to do. We move a term from one side of the equation, and let me just put a little thing here, and I should put to the other. Then change the sign. So that's what we're going to do. Okay, let's just click on here. Okay. So we have this right over here. Now we're going to group the x terms on the left side. The 5x is originally here. And we have the 7x is here, which is this term here. So the plus 3x is on the wrong side. We're going to change plus 3x from the right to the left and change the sign. So we have 5x plus 7x and 3x, and that takes care of all the variable terms. I moved the plus 3x from the right to the left. That's the only change I made here. Now, these numbers are on the wrong side. So initially I have 24 minus 24, that's this and this. And I've got minus 3 here, so that's this. I'm going to change the minus 15 from the left to the right and make it plus 15. And I'm going to change the minus 42 from the left to the right and make it plus 42. So I'm moving a term from one side of the equation to the other and then changing the sign. So 5x plus 3x, 5x plus 7x is 12x. 12x minus 3x is 9x. Same as saying 5 plus 7 is 12 minus 3 is 9. We got the x term as part of this whole operation. Now 24 minus 24 is 0. Minus 3 plus 15 is 12. 12 plus 42 is 54. So we get 9x equals 54. We divide the left side by 9. We get x. We divide the right side by 9 and we get 6. 54 divided by 9. So we know the solution to this equation is x equals 6. Now, by the way, in going from this to this line, you see I know that I have 1, 2, 3, 4, 5, 6, 7, 8 terms. I check that I have the right number of terms to go here. 1, 2, 3, 4, 5, 6, 7, 8. So I haven't changed. Now notice I don't do anything in my head. I set this up properly before I get all the variable on the left, all the numbers on the right, and then I do the arithmetic. Okay. Now to check the answer, and this is an important part of our process, here's the left side of the equation. I'm going to substitute x equal to 6 into the left side of the equation. So everywhere that x appears, I'm replacing it with a 6. So we have this right over here. This is the left side. So we have 5 times 6 minus 3. This is 3, which is 15. This part is 6 minus 6 is 0. 7 times 0 is 0. So we just have the 5 times the 3. Now I take the right side of the equation, rewrite it, and I replace the x with the 6 right over here. So this part stays the same. 8 minus 6 is 2. 3 times 2 is 6. Becomes that. Minus 3. So I have 15 minus 24 minus 9, which is 15. The left side equals the right side. If this answer were not correct, then the left side would not check the right side. So it's very important not only to get the solution, but to be able to check your answer. So once we've got the answer, we isolate the left side, and we don't look at the right side at all. We put the variable into the left side, work it out. Then we look at the right side, put the variable in, x equals 6 into that, calculate it, make sure that the left side equals the right side. Okay, let's go to page 4, number 1Q. We're going to use distributive rule. Implied here is a number 1 in front of the bracket. It's implied, even though it does not appear. This will help us with the distributive rule. Minus 1 times plus x gives us minus x right here. And minus 1 times minus 2 gives us plus 2 when we remove this bracket here. So we've got 2x. As I said, I put a minus 1 here, and then I use the distributive rule. This becomes 2x minus x. The minus 1 times the minus 2 becomes plus 2. And now I'm going to add 2x minus x. I get x. X plus 2 in this bracket here. Got the 3 here. And this minus 3 times 3 becomes minus 9. And minus 3 times minus 2x becomes plus 6x. Now there is something important here. When you've got two sets of brackets, we got the square brackets here and the rounded brackets inside. Always work from the inside out. Okay? So you'll always remove the inner brackets first. Don't try to remove this bracket, the square bracket, before you remove the inner one, the x minus 2. And that's what we've done. Remove the inner brackets first before we remove the outer bracket. Right here, where we do 3 times x, we get 3x. And 3 times plus 2 is plus 6. This stays the same. Now, remember what we said. We want the variable term on the left and the numbers on the right. So I'm going to move this 6x from the right to the left. It becomes changes sign. I'm going to move the plus 6 from the left to the right. Let me go over that again. This plus 6 is on the right. I move it to the left. It becomes minus 6x. The plus 6 on the left moves to the right and becomes minus 6. This 3x stays the same. This one stays the same. Now, 3x minus 6x is minus 3x. Minus 9 and minus 6 sum to minus 15. I can, if I've got a minus and a minus here, I can multiply both sides by minus 1. If I've got a minus and a minus, I can just change it to plus and plus, because essentially what I'm doing is multiplying the left side by minus 1 and the right side by minus 1. Alternately, you can move the 15 over here. Minus 15 over here becomes plus 15. Move the minus 3x to the other side, it becomes plus 3x. So whether you write 15 equals 3x or 3x equals 15, it's the same. So I divide this by 3, I get x. Divide this by 3, and I get 5. Now I go back and I check the left side of the equation, which is right over here. I'm going to substitute the x equal 5 into this side, and then separately substitute the x equals 5 into the right side right here. So we have left side 2x minus x minus 1 times x minus 2. Replace the x with a 5. Remove the inner bracket first. So 2 times 5 is 10. 5 times minus 2 is 3. Minus 1 times 3 is this term here. And I'm left with 10 minus 3, which is 7. 3 times 7 is 21. Go and check on the right side of the equation, replace the x with a 5. I got 2 times 5, which is 10, minus 10 here. And I have 3 minus 10, which is minus 7. Minus 3 times minus 7 is plus 21. I get the same thing on the left and the right. If this answer were not correct, then the left side would not equal the right side. So the first thing you do is check the answer, or work out the answer, and then check it by substituting it, replacing the variable. And that's what we've done here. Now, number 1t on page 4. We take this equation. I've rewritten it here. The only thing that I've done is put the 9. 9 means 9 over 1. I'm going to use the distributive rule after this. 4x is 4x. Now I'm going to multiply 9 over 1 times 5x over 9, which is this term right here. And then I'm going to multiply 9 minus 9 over 1 times minus 1, which gives me the minus, and the minus here gives me the plus, and this 9 over 1 is that, and this one is this, and the sign changes because I'm multiplying a minus times a minus here. So now this 9 and that 9 will cancel, and I'll have minus 5x, and 9 times 1 is just 9. So now what I'm going to do is move this from the left side to the right side and change the sign. And 4x minus 5x is minus 1x, or x. Minus 1 minus 9 is minus 10. If I multiply this by minus 1, I get x. If I multiply this by minus 1, I get 10. So I can just change this to a plus and this to a plus. And because we always want what a positive value of x is. We don't want minus x. We always want x here, plus x. Now I go back, and the left side of the equation, I replace the x with a 10. Okay, I'm going to do that. Well, first of all, what I'm going to do before I do that is I'm going to use the distributive rule. So here's 4x minus 9 over 1 times 5/9. The 9's cancel, and so I have minus 5x. And then minus 9 times minus 1 is plus 9. Now I'm going to do 4x minus 5x, gives me minus x. I'm going to replace the x with a 10. So I get minus 10 plus 9, which gives me minus 1. So first thing I do is use the distributive rule here before I do any replacement. So I multiply this term by this, and I get minus 5x. I multiply this term by this, and I get plus 9. Then finally I replace the x with a 10 here. Minus 10 plus 9 equals minus 1. And if you go back to the right side of the equation, it says minus 1. So I don't have to do anything there. And I've shown that the left side equals the right side. And that verifies that the answer is correct. Now, before I go any further, I just want to go over some rules of fractions, addition and subtraction of fractions, I'm going to take this problem and look at it and see what the solution is. Suppose I have to add 5/8 minus 8/3 plus 7/4. So I look for the lowest number, lowest common multiple of 2, 3, and 4, and that's 12. So the lowest number that 2, 3, and 4 will all go into is 12. So now I say 2 into 12. I take this 2 and I divide the 12 by this number 2 and I get 6. So I'm going to multiply the 5 times the 6. I say 12 over the 3 gives me 4. I'm going to multiply this 8 times the 4. 4 goes into 12 3 times, so I'm going to multiply the 7 times the 3. So let me go over that again. You choose the lowest common multiple, the lowest number that both 2, 3, and 4 will go into. Then I divide, which is 12. I divide 12 by this number, and I get 6. I divide 12 by this number, and I get 4. And I divide 12 by 4, and I get 3. So that's okay. So I got 5 times 6 is 30. 8 times 4 is 32. And 7 times 3 is 21. So when you add 30 and 21, you get 51. 51 minus 32 is 19. So the answer is 19 over 12. Now there's another way of doing it. If you don't want to do the least common multiple, you could just put 2, 3, and 4 in here. 2, 3, and 4 on the denominator. Okay? Now, obviously that won't give you the lowest common multiple, but the answer will still work out. You just take whatever the numbers are here and you put them down here. Now, since the 2 appears here and here, you multiply this 5 by the other numbers, 3 and 4. Because the 2 appears here and the 2 appears here, multiply by the other 2 numbers, 3 and 4. Here, the 3 appears here, so you multiply this 8 by the other numbers, which are 2 and 4. When you're doing this term, the 4 appears here, so you multiply the 7 by the other 2 numbers, 2 and 3. And when you work this out, this 5 times 3 is 15, 15 times 4 is 60, 8 times 2 is 16, 16 times 4 is 64, and 7 times 2 is 14, 14 times 3 is 42. You can do those all on your calculator if you can't do them in your head. So now I have 60 minus 64, which is minus 4, plus 42 is 38. I have 38 over 24. Well, 38 is 2 times 19, and 24 is 2 times 12. Can cancel the 2, and I come out with 19 over 12, which is the same answer that I got over here. So it doesn't matter whether you use method 1 or 2. Now let's say you have a variable and you have these. So as I said, you could put the 2, 3, and the 4 here, right? Since the 2 appears here, multiply the 5x by the 3 and the 4. Since the 3 appears down here, multiply the 8 term here by 2 and 4, right here. And since the 4 appears here, multiply the 7x by the 2 and the 3. So you've got all these terms. You can just isolate the x and just deal with the numbers. So here you again have the 60 term. Here you have the 64 term. And here you have the 42 term, and each of them has x. So when you sum them, 60 minus 64 is minus 4x. Minus 4x plus 42x gives you plus 38x. And you can reduce this and you get 19x over 12. So we're going to use this kind of information in the problems that we're going to do now. Okay, so we're back on page 4, number 1x, and here we see the problem. First thing I'm going to do is use the distributive rule. This x is this x. Minus 2 times plus x gives me minus 2x, and the 2 is 2 over 1. I'm going to multiply the minus 2 over 1 times minus a third. The minus times the minus gives me plus, and I have 2 and 1/3 here. This term stays the same. When I multiply the top times the top and the bottom by the bottom, I get the 2/3. This term is this term, that term is that term, and this is the 2/3 equals the 4/3 x. Now all I'm going to do is move this from the right to the left, and I'm going to take this term and move it from the left to the right. So when plus 2/3 on the left becomes minus 2/3 on the right, okay, and the plus 4/3 x on the right becomes minus 4/3 x on the left, because I want the variable term on the left and the number on the right. So x minus 2x is minus x. This is this, and that is that. So all I've done is combine these two terms. 1 minus 2 is minus 1. Now I'm going to take the common denominator here. This is over 1. So I'm going to put this all over 3 here. This 3 is this 3. This 3 is this 3. And you can see that this has to be the 3 divided by the 3 gives me the 1, which is implied in front of the x. So we have 3, 3, and 3. So we have the common denominator. And so I've got this right here. And what I can do is combine these two terms here, minus 3x minus 4x over 3, and this over 3. So the bottom right over here, the minus 3x and the minus 4x becomes minus 7x, and this becomes minus 2. Excuse me. And now if the bottom equals the bottom, the minus 7x equals the minus 2, which is the same as saying 7x equals 2. Divide this by 7 and divide this by 7. 7x divided by 7 is x. 2 divided by 7 is 2/7. So let's go over that again. We used the distributive rule first of all to go from here to here. I just multiplied this term out. Let's go back one line. Yeah. Use the distributive rule here. Minus 2 times plus x gave us this. Minus 2 times minus third gives me this term over here. These two numbers multiplied together, which come out to be 2/3. And this is 4/3 x. Now all I've done is get all the x terms on the left and the numbers on the right. So I transposed this to this side and this one from the left to the right and changed their signs. So I combined the x minus the 2x. I got minus x. This is the same as this, and that's the same as that. Now all I've done is make the denominator here for this the same as the denominator here. So this is really minus 3x over 3. You can see the 3's cancel, you get minus x. I have a common denominator of 3, 3, 3 here. I've combined these two terms under the 3 here. This one stays the same. Minus 3x minus 4x is minus 7x. This is minus 2. And now I've actually multiplied this left term by 3 and this right term by 3. So if I put a 3 here and I put a 3 here, I get 7x equals 2, because I can also change the sign here, minus 7x minus 2. If minus 7x is equal to minus 2, and the denominators are the same, another way of doing it is just to say the 7x equals 2. So you can do it in a number of ways. You can multiply both sides by 3, or you could multiply both sides by minus 3. You'll still come out to this term here. And when we solve that, we get x equals to 2/7. Now, if I want to replace, as I said, the left side is x minus 2x plus this term here. X minus 2x is minus x plus 2/3. Instead of the x, I'm going to put 2/7, but there's a minus in front of it. Now I'm taking the two terms, 7 and 3. Since the 7 appears down here, I'm going to multiply the left term by 3. If I have this term the same as this one right over here, then I multiply the remaining part by 7, so 2 times 7. So this is minus 6 plus 14, which comes out to be 8, and the 7 times 3 is the 21. So same thing if I go to the right side and I get 4/3 x, I replace the x with the 2/7. 4 times 2 is 8. 3 times 7 is 21. I get 8 over 21. I can't reduce that anymore. This is 8 over 21. So the left side equals the right side. Now here we're going to do decimals. Problem involving decimals. Here you can see first thing we're going to do is remove this bracket, use the distributive rule. 0.05 times 20 gives me 1. 0.05 times minus x gives me that term. 0.09 times 20 is 1.8. You can do those on your calculators. So if this term is the same as this, now what we're going to do is transpose this term from the left to the right, and it becomes minus 1 right over here. So we have 0.05x, 0.1x minus 0.05x are these two right here. And this one, the only difference is this one term here is transposed and made minus. Now, if I add these two terms, I get 0.05x. If I add these two terms, I get 0.80. Divide the left side by 0.05. Divide the right side by 0.05. And x comes out to be equal to 16 as the solution to this problem. So now I go and I check the answer, and I replace the x in the left side of the equation by 16. Here I replace this by 16 and this by 16. This is in the original equation right over here. So I rewrite the left side of the equation here and replace the x with the 16. I've replaced it here and I've replaced it here. So 0.1 times 16 is 1.6. 20 minus 16 is 4. I'm going to multiply the 4 times the 0.05. I get 0.2. 1.6 and 0.2 gives me 1.8. The right side is 1.8. Left side equals the right side. If x equals 16 were not the correct answer, I got another value, then this would not work out. Okay, so now we're going to do some word problems where we translate the equation into an algebraic equation. So we're looking at a problem where it says the sum of a number and 15 more than itself is 85. So let's say the number is x, then x plus 15 is 15 more than itself. So we're saying the sum of a number and that number plus 15 is 85. The sum of the number and that number plus 15 equals 85. That's what's meant by 15 more than itself. So we have one number which is x, we have a second number which is x plus 15, and the sum is 85. So now I remove the brackets here. X plus x gives me the 2x, and I've still got the 15 here equals 85. Transpose the 15 from the left side to the right side. I have minus 15. So 85 minus 15 is 70. Divide this by 2, I get x. Divide this by 2, I get 35. So one of the numbers is 35, and 15 more than the number, 35 plus 15 is 50. So 35 plus 50 is 85. So I've done this over here. I've said the left side is 2x plus 15. 2 times 35, replace the x with the 35. 70 plus 15 is 85, and the right side is 85. This is the original equation, 2x plus 15 right here. So I'm checking that, replacing the x with the 35 in both sides there. Find the number such that the sum of itself and 12 less than 4 times itself is 28. So again, we have to translate this into equation. Find the number. Let x equal the number. The sum of itself and 12 less than 4 times itself. So 4 times itself is 4x, and 12 less is minus 12. So this is the other number. We're thinking of two numbers, the sum of itself and the number that is 4 times that less 12, sums to 28. So here's the number, 4 times itself less 12 sums to 28. We remove the brackets. This 4x becomes this 4x. Minus 12 becomes minus 12. Now what we're going to do is group the variable on the left. Here it is. Transpose the minus 12 from the left to the right. We get plus 12. So we have x plus 4x is 5x. 28 plus 12 is 40. Divide the left side by 5. I get x. Divide the right side by 5. I get 8. So the number is 8. Okay, so let's check the left side. This is the number and 4 times the number minus 12. So 8 is the number. 4 times 8 is 32. 32 minus 12 is 20. 8 plus 20 is 28. The right side of the equation is 28. That's right here. Left side equals right side, so this must be the right solution. I mean, you can do it in your head here. You find a number such the sum of itself 8, and 4 times 8 is 32, less 12 is 20. 8 and 20 gives you 28. So that completes page 4 and the problems that we are going to do on page 4.